When we think of American tanks in World War II, images of the legendary M4 Sherman rolling across European battlefields immediately come to mind. But what if I told you that behind the scenes, American engineers were designing some of the most innovative, bizarre, and downright deadly armored vehicles the world has never seen? These weren't just blueprints gathering dust in forgotten archives. These were fully developed prototypes, revolutionary concepts that pushed the boundaries of tank warfare, and secret projects that could have changed the entire course of the war. Some were too ambitious, others were too expensive, and a few were simply too strange for the battlefield. Today we're diving deep into the classified world of America's secret tank programs during World War II. From super heavy monsters that could crush enemy positions, to amphibious marvels designed for island hopping, to flame-throwing nightmares that would haunt any defender's dreams. Let's begin with arguably the most infamous of America's secret tanks, the T28 Super Heavy Tank, also known as the T95 gun motor carriage. This beast wasn't just a tank, it was a mobile fortress designed for one specific purpose: breaking through Germany's Siegfried Line. Picture this: 95 tons of American steel, protected by armor up to 12 inches thick in some places. To put that in perspective, the standard Sherman tank had armor just 2 inches thick. The T-28 was built like a bunker on tracks. It featured a revolutionary 4-track system. Yes, 4 tracks. The outer tracks could be removed for transport, but when attached, they distributed the enormous weight across a wider surface area. The main armament: a devastating 105 mm T5 E1 gun capable of destroying any fortification the Germans could build. The designers envisioned this monster slowly crawling toward enemy fortifications at just 8 miles per hour, shrugging off anti-tank fire like rain, while its massive gun systematically demolished concrete bunkers one by one. Development began in 1945 and 2 prototypes were actually built. But here's where the story gets interesting. By the time the T-28 was ready for testing, American forces had already broken through the Siegfried Line using conventional tactics and air power. The tank's primary mission had evaporated. But the project continued for evaluation. During testing, engineers discovered serious problems. The weight made it nearly impossible to transport. Bridges couldn't support it. The tracks wore out constantly, and that 8 miles per hour top speed, in reality, it could barely manage 5 miles per hour cross-country. Then came one of the strangest chapters in military history. One of the 2 prototypes simply disappeared. For decades, nobody knew where it went. Finally, in 1974, it was rediscovered in a field behind Fort Belvoir, Virginia, partially buried and forgotten. Today you can see this survivor at the Patton Museum at Fort Benning, Georgia, a testament to American ambition and engineering excess. While the T-28 was designed to break fortifications, the Army recognized another need: a heavy tank that could go toe-to-toe with Germany's fearsome Tiger II and the monstrous Jagdtiger. The answer was the T-29, T-30, and T-34 heavy tank series, America's attempt to build a true heavyweight champion. The T-29 weighed in at 64 tons and packed a powerful 105 mm T5 E1 gun in a massive cast turret. This was the same gun planned for the T-28, but now mounted in a fully rotating turret with much better mobility. The armor was impressive too, 7 inches on the front turret, making it nearly immune to German 88 mm guns at combat ranges. But American engineers thought, if 105 mm is good, wouldn't 155 mm be better? Enter the T-30. This variant mounted a colossal 155 mm gun, essentially a self-propelled artillery piece with armour. The gun was so powerful it could destroy any German tank with a single shot, and its high-explosive shells could obliterate fortifications. The T-34 represented a middle ground, mounting a 120 mm gun that balanced firepower and ammunition capacity. All three versions shared the same basic chassis and used the powerful Ford GAC engine, actually 8 Ford V8 engines linked together, producing 770 horsepower. These tanks were technological marvels. They featured torsion bar suspension for a smoother ride, an advanced transmission, and sophisticated fire control systems. The crews had much better working conditions than in a Sherman, with more space and better visibility. So why weren't they mass-produced? Timing, cost, and the atomic bomb. The first prototype wasn't completed until the war in Europe ended in May 1945. Each tank cost several times more than a Sherman. And by the time they were ready for potential use against Japan, the atomic bombs had been dropped, ending the war. The Army did build about 20 prototypes across all variants for testing. These monsters influenced post-war American tank development, with many features appearing in later designs. Several survive in museums today, silent giants that represent what might have been. Before the T29 series, there was an earlier American attempt at a heavy tank, the M6. And this story is a cautionary tale about military bureaucracy and the challenges of tank development during wartime. Development of the M6 began in 1940, when American military observers in Europe witnessed the effectiveness of German and French heavy tanks. The Army wanted something that could match or exceed anything the Axis powers could field. The M6 was actually an impressive machine on paper. Weighing 57 tons, it featured a 76.2 mm M7 gun, thick armour up to 3.5 inches, and a top speed of 22 miles per hour, quite good for a heavy tank. It had a crew of 6 and bristled with weapons, the main gun, 2 hull-mounted .50 caliber machine guns in sponsons, like a World War I tank, and additional .30 caliber machine guns. But here's where things went wrong. The design process was plagued by committee decisions and constant changes. Should it have a welded hull or cast? What gun should it mount? How thick should the armour be? Every time engineers got close to finalizing the design, someone in the War Department wanted changes. By the time the M6 entered production in 1942, military thinking had changed dramatically. General Leslie J. McNair, head of Army Ground Forces, strongly opposed heavy tanks. He believed they were too heavy to transport overseas, too expensive, consumed too much fuel, and that the Sherman was good enough for American needs. Only 40 M6 tanks were ever built, and not a single one saw combat. Instead, they spent the war at training bases in the United States, used to train crews and test new equipment. The crews who trained on them often joked they were preparing to fight a war that didn't exist. The M6's failure taught the Army valuable lessons about tank development. Streamline the design process. Don't try to make one tank do everything, and sometimes good enough really is good enough. The Sherman, despite its flaws, proved this philosophy correct through sheer numbers and reliability. But one has to wonder, what if America had committed to heavy tank production earlier? How might battles like the Battle of the Bulge have played out differently? Now let's shift gears from European-focused heavy tanks to the Pacific theatre, where America faced a completely different challenge. How do you get armour support onto a beach when there's no beach yet? The answer was the LVT-A-4, part of the Landing Vehicle Tracked family. While not exactly secret, the advanced variants and experimental versions of these amphibious tanks were definitely kept under wraps. The LVT-A-4 wasn't just a tank that could swim, it was a swimming vehicle that could fight like a tank. It mounted a 75 mm howitzer in an open-topped turret, the same weapon used by the Sherman. But unlike a Sherman, this vehicle could cross reefs, navigate through surf, and crawl onto beaches, while providing direct fire support to infantry. Think about the tactical advantage. Instead of landing unarmoured infantry, who then had to wait for tanks to be offloaded from ships, the LVT-A-4 could lead the assault, suppressing Japanese bunkers and pillboxes from the moment it emerged from the water. These vehicles saw extensive action at Tarawa, Saipan, Peleliu, Iwo Jima, and Okinawa. At Iwo Jima, over 250 LVT-A-4S participated in the assault, providing crucial fire support as Marines struggled across the volcanic sand beaches. But what about the secret variants? The Army experimented with several advanced versions that never saw production. The LVT-A-4 with flame-throwing capability could swim to shore and then blast Japanese fortifications with napalm. Imagine the psychological impact, a tank emerging from the ocean, spewing fire. Another experimental variant mounted a 105 mm howitzer, even more firepower in an amphibious package. Engineers also tested versions with additional armour plating, rocket launchers, and even one prototype with a flamethrower and a 75 mm gun. The key to the LVT's swimming ability was its track design. The tracks had special grousers, metal pieces that acted like paddles in water. The hull was waterproofed and shaped to plane across the surface at speeds up to 7 miles per hour in water. These amphibious tanks proved so successful that similar concepts influenced post-war American amphibious vehicle development for decades. The modern AAV-7, still used by the Marines, is a direct descendant of the wartime LVT family. Landmines were one of the most feared weapons in World War II. They were cheap to produce, easy to deploy, and deadly effective. Engineers needed a way to safely clear paths through minefields. The solution: some of the strangest-looking armoured vehicles ever conceived. Enter the T1E one-mine exploder, nicknamed Aunt Jemima, though nobody today is quite sure why. This contraption consisted of a Sherman tank pushing 2 massive steel rollers, each 10 feet in diameter, ahead of it. The concept was brutally simple. The heavy rollers would roll over mines and detonate them before the tank reached that spot. Each roller weighed several tons and was designed to withstand multiple mine explosions. The tank crew would simply drive forward slowly, letting the rollers do their dangerous work. Testing revealed both promise and problems. The system-worked mines did explode harmlessly under the rollers, but the device made the tanks slow, difficult to maneuver, and the rollers themselves sometimes threw up debris that could damage the tank behind them. Engineers developed multiple variants. The T1E3 used smaller but more numerous rollers. The T1E4 tried different spacing and configurations. Each iteration tried to solve the fundamental problems: weight, speed, and effectiveness. Ultimately, the British flail system proved more effective for most situations. This used a rotating drum with chains that beat the ground ahead of the tank, detonating mines. The American T1E1 and its variants saw limited use, primarily in the Pacific where mines were less dense and the terrain was different. But dozens of these mine-clearing tanks were built and tested. Some did see combat in Italy and France. Their mere presence was valuable. Combat engineers could use them to clear paths for following forces, even if they weren't perfect. The lesson learned: sometimes the simplest-looking solution to a problem is actually incredibly complex to implement effectively. The mine roller concept would continue to evolve, and modern armies still use roller and flail systems on their combat engineering vehicles today. What happens when America and Britain try to design a tank together? You get the T-14 assault tank, a fascinating example of international military cooperation that ultimately went nowhere. In 1941, Britain desperately needed tanks and had specific ideas about what they wanted. American tanks, while appreciated, didn't quite meet British requirements for infantry support. So the two nations agreed to jointly develop a specialized assault tank. The T-14 incorporated British design philosophy with American manufacturing capability. It featured very thick armor, up to 4 inches in places specifically angled to maximize protection. The cast hull was a one-piece design, revolutionary for the time and made possible by American foundry technology. The turret mounted a 75 mm gun and was designed to accommodate 3 crew members, comfortably more space than most tanks of the era. British tankers had complained about cramped American design, so this was addressed specifically. At 47 tons, the T-14 was substantially heavier than a Sherman, but this weight brought excellent protection. The suspension system used vertical volute springs, proven American technology that gave a smooth ride and was easy to maintain. 2 pilots were built at the Aberdeen Proving Ground. Testing revealed a competent tank that did everything it was designed to do. The armor worked, the gun was adequate, mobility was acceptable, if not spectacular. So why didn't it enter production? By 1943, when the T-14 was ready for evaluation, circumstances had changed dramatically. Britain was now receiving massive quantities of Shermans through Lend-Lease. These were familiar, parts were available, crews were trained on them, and they were good enough. The T-14 was more expensive to produce than a Sherman, and offered only marginal improvements in protection at the cost of weight and mechanical complexity. The British Army decided that standardizing on the Sherman made more logistical sense than introducing another tank type into their inventory. Only those 2 pilots exist, and one survives today at the Tank Museum in Bovington, England, a tangible reminder of the might-have-been of Allied tank cooperation. The T-14 represents an interesting road not taken in tank development, where rational logistical decisions trumped technical excellence. Hidden in the shadow of the Sherman was one of the most innovative American tank designs of World War II, the T-23 medium tank. At first glance, it looked like just another Sherman variant, but under the hood, it was revolutionary. The T-23 featured an electric drive transmission, the first American tank to use this technology. Instead of a traditional mechanical transmission with gears, the tank's engine drove an electric generator. This generator powered electric motors connected to the drive sprockets. Why was this significant? Electric drive offered several advantages. First, it was much smoother and easier to drive, no gear shifting, no clutch. The driver simply had a control lever that varied the power to the drive motors. This made the tank much easier to learn to operate. Second, electric motors provide maximum torque at all speeds. This gave the T-23 excellent acceleration and the ability to maintain speed over rough terrain. Third, the system was actually more compact than a traditional transmission, freeing up internal space. The T-23 also pioneered the turret design that would later be used on 76 armed Shermans. This turret provided better protection and more internal space than the original Sherman turret. When American commanders realized they needed better anti-tank firepower, the T-23's turret was adapted to fit the Sherman chassis. So why didn't the T-23 itself go into mass production? The electric drive system, while innovative, required lots of copper for the generators and motors. Copper was a critical war material, needed for countless applications from ammunition to electronics. Diverting large quantities of copper to tank production didn't make strategic sense. Additionally, the electric drive components were more delicate than purely mechanical systems. They were vulnerable to combat damage, and repairs required specialized knowledge that most tank crews and field mechanics didn't have. About 250 T-23 tanks were built, but instead of being shipped to combat zones, they were kept in the United States for training and testing. The crews who trained on them loved the smooth driving characteristics, but that wasn't enough to justify combat deployment. However, the T-23 wasn't a failure. It proved the concept of electric drive in tanks. The technology was ahead of its time, and modern tanks like the German Leopard 2 and British Challenger 2 use hybrid or electric drive systems based on principles proven by the T-23. The T-23 represents American willingness to experiment with radical new technologies. Even when traditional solutions were working, it's a testament to the innovative spirit of American engineering during the war. Of all the weapons developed during World War II, few were as terrifying and effective at close range as the flamethrower. Now imagine that weapon mounted on a tank. The result was a series of flame-throwing Sherman variants that became devastating tools in Pacific Island fighting. The most famous was the POA CWS H-5, where POA stood for Pacific Ocean Areas and CWS for Chemical Warfare Service. This wasn't just a Sherman with a flamethrower strapped on it, it was a carefully engineered fire-breathing weapon system. The flame gun replaced the bow machine gun. It could project burning napalm up to 150 yards farther than most people realize. The fuel was stored in armored tanks inside the hull, theoretically protected from enemy fire. The system was pressurized with nitrogen to maintain consistent projection distance and pressure. These tanks were specifically designed to deal with Japanese fortifications. Pacific Islands were honeycombed with concrete bunkers, caves, and tunnels. Standard high-explosive shells often couldn't penetrate or would require dozens of direct hits. But flame weapons were perfect. Even if the flame didn't reach deep into a cave system, the fire consumed all available oxygen, suffocating defenders. The psychological effect was immense. Japanese soldiers who might hold out against conventional weapons often abandoned positions when flame tanks approached. The sight and sound of a 60-foot stream of fire was deeply terrifying. But operating a flame tank was arguably the most dangerous job in the armored force. If enemy fire penetrated the fuel tanks, the result was catastrophic. Crews knew they were high-priority targets. Japanese soldiers specifically targeted flame tanks with anti-tank weapons, satchel charges, and suicide attacks. The Army developed several variants. The M4A3R3, nicknamed Zippo, had improved fuel capacity and better protection for the flame system. The E45 variant used a different projection system that was more reliable. Each iteration tried to address the fundamental problem. How do you make a mobile napalm dispenser survivable in combat? On Iwo Jima, flame tanks were instrumental in reducing Japanese fortifications. They worked in teams with conventional Shermans and infantry. While standard tanks provided covering fire and suppressed enemy positions, the flame tanks would approach and methodically burn out each defensive position. At Okinawa, flame tank crews developed refined tactics. They would use terrain for cover, approach from unexpected angles, and often fire short bursts to conserve fuel rather than long, spectacular flames that looked impressive but wasted precious fuel. The Army kept many flame tank developments classified. Experimental systems included multiple flame projectors for wider coverage, longer-range projection systems using higher pressure, quick-change fuel tanks for faster refueling, improved ignition systems for more reliable operation. After the war, flame tanks continued to see use in Korea and Vietnam. The concept proved enduring because the fundamental tactical problem, clearing fortified positions, remained relevant. The flame tanks of World War II established doctrines and designs that influenced military planning for decades. For the crews who operated them, flame tanks were both the most feared and most effective tool available. Their story is one of incredible bravery and technological innovation in the face of one of warfare's most difficult challenges. Even as Sherman tanks were rolling off assembly lines by the thousands, American engineers were already working on its replacement. The T-20 series represented the next generation of American medium tank design, incorporating lessons learned from early combat experience. The T-20 looked superficially similar to a Sherman, but nearly everything was improved. It featured torsion bar suspension instead of the Sherman's vertical volute springs, providing a smoother ride and better cross-country performance. The armor was better angled for increased protection without adding excessive weight. The hull was lower and wider, making it a smaller target while providing better internal space. The engine and transmission were mounted differently, improving crew compartment layout. Everything about the T-20 screamed modern tank design. Multiple variants were developed simultaneously, a common American practice of building prototypes with different characteristics to see which worked best. The T-22 featured an experimental automatic loading mechanism for its 76 mm gun. This allowed a higher rate of fire since the human loader was replaced by a mechanical system. However, the autoloader proved unreliable and added significant complexity. The T-23, as we discussed earlier, used electric drive. The T-25 and T-26 mounted the powerful 90 mm gun, the same weapon that would later arm the M26 Pershing heavy tank. This gun could defeat any German tank at combat ranges. So with all these improvements, why didn't the T-20 series replace the Sherman? The answer is timing, logistics, and the old military maxim, quantity has a quality all its own. By 1943, when the T-20 series was ready for evaluation, Sherman production was running at full capacity. Thousands of Shermans were in service, crews were trained on them, supply chains were established, maintenance procedures were standardized. Switching to a new tank would mean retooling factories, months of lost production, retraining all crews and maintenance personnel, creating new supply chains for different parts, dealing with logistics nightmares of supporting two different tank types simultaneously. General Leslie McNair and other Army Ground Forces leaders argued that the Sherman was adequate, and that America's advantage lay in numbers, not technical superiority. They believed tactical doctrine and combined arms tactics would overcome any German technical advantages. However, work on the T-20 series wasn't wasted. The experience and technology directly led to the M26 Pershing heavy tank, which did see limited service in the final months of the war. The T-26 essentially became the Pershing after additional development. The T-20 series represents what military historians call a transitional design. It bridged the gap between the Sherman era and the post-war generation of American tanks. Elements of the T-20 appeared in the M46 Patton, M47 and M48 tanks of the 1950s. For tank enthusiasts, the T20 series is fascinating because it shows American engineers weren't complacent. They were constantly innovating and improving, even when the current design was successful. Several T20 series tanks survive in museums today, allowing us to see these missing links in American tank evolution. While most of our focus has been on heavy and medium tanks, American engineers were also working on the other end of the spectrum. Ultralight tanks that could be dropped from aircraft or transported by glider. The T-92 light tank was designed to provide airborne troops with armoured fire support. At just 18 tons, it was light enough to be air transportable, yet still packed a useful 76 mm gun, the same weapon used on late-war Shermans. The design was revolutionary for a light tank. It used an oscillating turret, the entire turret tilted up and down instead of just the gun. This allowed the gun to elevate and depress at extreme angles while keeping the turret size minimal. The concept was way ahead of its time. Oscillating turrets wouldn't become common until the 1950s. The crew of 3 was extremely cramped, but the tank's low silhouette made it a difficult target. The height was only 6 feet compared to a Sherman's 9 feet. This made concealment much easier. The Army envisioned dropping multiple T-92s by parachute during major airborne operations. Imagine D-Day, but instead of paratroopers fighting with small arms against German armour, they'd have their own tanks within hours of landing. Development accelerated in 1945 with the expectation that the invasion of Japan would require massive airborne operations. The T-92 could be broken down into components small enough to fit in cargo aircraft, then rapidly reassembled after landing. But here's where reality intervened. The atomic bombs ended the war before the T-92 could be perfected and deployed. Without the need for an invasion of Japan, the urgency disappeared. Only 2 prototypes were completed. Post-war evaluation showed promise, but also revealed problems. The oscillating turret, while innovative, had ceiling issues. The small size made crew comfort terrible for extended operations. And America's post-war airborne doctrine shifted away from heavy equipment drops. However, the T-92 influenced later American light tank development. The M41 Walker Bulldog light tank of the 1950s incorporated several lessons learned from the T-92. And the concept of air-droppable armour would resurface decades later with the M551 Sheridan. The T-92 represents American thinking about future warfare: fast, mobile, air-deployable forces that could bring significant firepower anywhere in the world quickly. It was a concept ahead of its time, limited by the technology of the era, but prescient in its vision. Now we enter the realm of truly strange and highly classified systems. The Canal Defense Light, or CDL, wasn't designed to shoot enemies, it was designed to blind them. The CDL system consisted of a powerful carbon arc searchlight, one of the brightest lights ever installed in an armoured vehicle, mounted in a specially designed turret on a Grant or M3 Lee tank chassis. The light was so intense it could illuminate targets over a mile away and temporarily blind anyone looking at it. But here's where it gets interesting. The turret had a narrow vertical slit, and a rapidly spinning shutter inside could create a flickering strobe effect. This was designed to disorient and confuse enemy troops, making it difficult for them to aim accurately. The concept was brilliant. Advanced CDL tanks at night toward enemy positions. The intense flickering light would blind defenders, while illuminating them for following conventional tanks and infantry. Attacking forces would have perfect visibility, while defenders were blinded and disoriented. The project was so secret that tank crews training on CDL tanks weren't told what they were training for. The turrets were covered, and training exercises were conducted in remote areas away from prying eyes. Even the name Canal Defence Light was deliberately misleading. It had nothing to do with canals or defence. Over 300 CDL tanks were built by the British and Americans. Entire specialised units were formed and trained. The British created the 35th Tank Brigade specifically for CDL operations. The Americans formed the 738th Tank Battalion Special. So why have most people never heard of them? Because they almost never saw combat. The CDL was so secret that commanders didn't know how to use them. There was fear that if the Germans captured one and understood the system, they could develop countermeasures. The CDL saw extremely limited action. A few were used during the Rhine crossing in March 1945, primarily for illumination rather than the disorienting role. Some were used as searchlights for night operations in Italy. Most sat unused, their crews frustrated by the secrecy and lack of employment. Post-war analysis suggested the CDL could have been effective if used correctly. The few times it was employed, it did disorient defenders, but the excessive secrecy meant it was never integrated into tactical doctrine properly. The CDL represents a uniquely World War II approach to psychological warfare, using technology to confuse and disorient rather than simply destroy. Modern military forces use similar concepts with laser dazzlers and other non-lethal directed energy weapons. Several CDL tanks survive in museums, and seeing one in person is striking. The massive turret housing the light system looks completely unlike any fighting vehicle, which is exactly what the designers intended. It's a weapon that doesn't look like a weapon. American engineers recognized early that tanks could serve as stable platforms for rocket artillery. This led to several experimental and operational rocket launcher systems that turned standard tanks into mobile rocket batteries. The most famous was the T-34 Calliope, officially the rocket launcher T-34. This system mounted 64.5-inch rocket tubes in a frame above a Sherman's turret. The entire launcher could traverse and elevate with the turret, allowing aimed fire. When all 60 rockets were fired in a rapid salvo, the effect on enemy positions was devastating. The Calliope could deliver the explosive equivalent of several artillery batteries in seconds. It was primarily used against fortifications, troop concentrations, and to suppress enemy positions before attacks. The psychological effect was significant. The sound of dozens of rockets launching simultaneously, followed by the explosions, was terrifying. German troops nicknamed it the Screaming Mimi, though that name properly belongs to a German rocket system. But the Calliope wasn't the only rocket tank experiment. The T-40 Whiz-Bang used a different launcher design with larger rockets. The T-76 system mounted multiple rocket launcher boxes on a Sherman's hull sides. Engineers experimented with different rocket calibers and ranges, automated loading systems, mostly unsuccessful, armoured launcher boxes to protect rockets from small arms fire, quick-release systems so the launcher could be jettisoned if it became a liability. The fundamental problem with all rocket tank designs was accuracy. Unguided rockets of the era were notoriously inaccurate. They were area weapons, not precision instruments. This limited their tactical utility. They were excellent for suppressing a town or a hillside, but useless against point targets. Additionally, the launcher systems added significant weight and made the tank top-heavy. The rocket tubes could be damaged by enemy fire or environmental factors. And once the rockets were expended, the tank was left with a bulky, useless launcher until it could return to reload. Despite these limitations, about 800 Calliope systems were built. They saw combat in northwestern Europe and in limited numbers in Italy and the Pacific. Commanders who understood their proper use as area suppression weapons supporting attacks found them valuable. The rocket tank concept influenced post-war development. Modern multiple rocket launch systems like the M270 MLRS trace their doctrinal roots to these World War II experiments. The idea of mobile, heavily armed platforms delivering rapid, devastating fire support remains relevant today. Let's return to the T28 Super Heavy Tank for a deeper look at the incredible engineering challenges it presented. This wasn't just a big tank, it was a mobile engineering laboratory that pushed American tank design to its absolute limits. The track system alone was a marvel. Each of the 4 tracks had to be independently sprung and synchronized to work together. When the outer tracks were removed for transport, the vehicle had to remain balanced and operational. This required sophisticated load calculations and stress analysis. The engine was a Ford GAF, essentially a high-performance version of the engine used in the Sherman but pushed to its limits. Moving 95 tons required enormous power, and the engine ran constantly at high load. Cooling was a significant challenge. The radiators were massive and still barely adequate. Steering was accomplished through a controlled differential system, a complex mechanical arrangement that varied the speed of tracks on either side. At the T28's weight, the forces involved were enormous. The steering mechanism was built like a bank vault, with huge gears and bearings. Transportation became a nightmare scenario. No standard military transporter could carry it. Railroads had weight limits that prohibited moving it in many areas. Bridges collapsed or were deemed unsafe. The Army had to plan special routes and reinforce transporters just to move the prototypes around. In combat conditions, the logistical challenges would have been insurmountable. It couldn't cross most rivers without engineer support to build special bridges. It couldn't travel on many roads without damaging them. Its fuel consumption was so high that keeping it supplied would require dedicated fuel trucks. The vision was for these tanks to be deployed by heavy rail to near the front lines, then to slowly advance, destroying fortifications. But American commanders ultimately decided that air power and artillery could achieve similar results with much less complexity. Beyond the exotic weapons and armor systems, some of the most important secret developments were the specialized engineering tanks that never get the recognition they deserve. These unglamorous vehicles made major operations possible. The Sherman dozer tank equipped with the M1 dozer blade could clear obstacles, fill ditches, create fighting positions, and clear roads. In the Pacific, these tanks were essential for creating paths through jungle and rubble. In Europe, they cleared debris in destroyed cities. The Rhino tank with the hedgerow cutter was developed to deal with the bocage of Normandy. The hedgerows, ancient earthen banks topped with thick vegetation, channeled American tanks into kill zones. An American sergeant named Curtis G. Coolin designed a simple blade device made from German beach obstacles that allowed Shermans to punch through hedgerows instead of climbing over them. The Beach Armored Recovery Vehicle, BARV, was essentially a Sherman with a tall, armored superstructure, waterproofing and towing equipment. It could drive into water up to 9 feet deep to recover disabled vehicles on invasion beaches. These unglamorous vehicles saved dozens of tanks and vehicles during amphibious operations. The M32 tank recovery vehicle removed the turret and installed a boom, winch, and tools. It could recover disabled tanks under fire, perform field repairs, and tow vehicles to safety. Tank crews loved having M32s nearby because it meant disabled tanks weren't abandoned. bridge layers could deploy portable bridges across ditches, streams, and destroyed bridges. These allowed armoured units to maintain momentum instead of waiting for engineers to construct bridges manually. All these specialised variants were essential to combined arms operations. They're not as glamorous as flame tanks or super heavy breakthrough tanks, but they made victory possible by solving mundane but critical problems. We've journeyed through the fascinating world of America's secret, experimental, and limited production tanks of World War II. From the monstrous T28 Super Heavy Tank to the innovative electric drive, T-23 from swimming, amphibious assault vehicles to fire-breathing flame tanks, from rocket-launching calliopes to the bizarre Canal Defense Light. These vehicles represent American innovation, engineering ambition, and the willingness to experiment with radical ideas. Some were ahead of their time, others were solutions to problems that disappeared. Many were simply too expensive, too complex, or arrived too late to see combat. But none were failures. Each contributed to the evolution of armoured warfare. The lessons learned from the T29 Heavy Tanks influenced the M26 Pershing. The T-23's electric drive reappeared in modern tanks decades later. The amphibious LVTs established doctrines still used today. Even the T-28, that magnificent white elephant, taught valuable lessons about the limits of armour protection. These secret tanks remind us that warfare drives innovation, often in unexpected directions. They show us the roads not taken, the what-ifs of military history. And they demonstrate that behind every successful weapon system are dozens of experiments, prototypes, and ideas that contributed to the final design. Today, these rare survivors sit in museums around the world, silent testaments to a period of rapid technological advancement and the dedicated engineers and tank crews who pushed the boundaries of what was possible. The next time you see a Sherman tank in a museum or documentary, remember that it wasn't alone. Behind it was an entire family of experimental vehicles, each representing American determination to build better, stronger, and more innovative fighting machines. These are the secret tanks America planned but never used, and their story is just as important as the tanks that won the war.